Hello and welcome to another exciting chemistry session. This is your host, Mr. Monsa, chemistry tutor. So we are still in the series of organic chemistry and we're still looking at alkanes. So for today we're going to look at the process called cracking in alkanes. So alkanes undergo the process known as cracking. So what is cracking? So cracking is just the breaking down of a large molecule of a hydrocarbon. So we have a large chain of a hydrocarbon which is broken down into simpler, smaller units or simpler, smaller molecules. So it's a large molecule, it's a large chain, and then you break it down into smaller or simpler units, which are just smaller molecules. So that is basically what is called cracking. There are two types of cracking. We have what is known as a thermal cracking, and we have what is known as a catalytic cracking. So thermal cracking, as or going by its name, thermal. So anything that uh, uh, is thermal involves the use of heat. So for thermal cracking, we're using heat to break down this large chain, and then we produce smaller units. Then catalytic cracking, by the word catalytic, it means there is a catalyst involved. So this is where both heat and a catalyst is involved. So a catalyst is there to speed up the process of breaking so that we can achieve these, we can produce the smaller units in the shortest possible time. That is the main use of catalyst. And the common catalysts that we use are aluminium oxide and silica or silicon for oxide. Under cracking, we're going to look at cracking in the absence of hydrogen and cracking in the presence of hydrogen. So when we have a large chain of hydrocarbon, when we have a large chain of a hydrocarbon, and then we want to break it into small units, we have the cracking that happens in the presence of oxygen, in the presence of hydrogen, and we have the cracking that happens in the absence of hydrogen. So let's talk about cracking in the presence of hydrogen. Cracking in the presence of hydrogen. So let me just use H2. So in the presence of hydrogen. So when we have, looking at just a general equation, when we have an alkane and then it undergoes cracking in the presence of hydrogen. So in the presence of hydrogen, we put a hydrogen molecule on top of the arrow, and then we produce an alkane plus alkane. So cracking in the presence of hydrogen produces alkane and alkane. Let me give an example. Let's use okay, we can use butane. So butane is C4H10. So when butane undergoes cracking in the presence of hydrogen, let's take it that we have an alkane of C2H6. So C2H6. So this is butane. This is butane. and then it produces ethane. So we are breaking down a large chain of butane. So when we break it, we produce ethane plus, let's take it that we get CH, then we'll say X, Y. Then our duty is to find out what CXHY is. So when it comes to cracking, when we break down a large molecule and then we produce smaller or simple molecules on the other side as products, what is cardinal here is that the number of atoms on the left should be equal to the number of atoms on the right. So when we check on the left, we're going to notice that we have 4 carbons and we have 10 hydrogens. Then on the other side we have 2 carbons. Then we have 6 hydrogens. So, like I said earlier on, the number of atoms on the other side should be equal to the number of atoms on the product side. So that is the basic principle when it comes to cracking. You just balance the number of atoms. So if we have C2 on the product side and we have C4 on the reactant side, what is X? So there X is equal to, so we just get the 4 which is on the other side, we subtract 2, then it means that we have 2. So the Cx is supposed to be C2. What about the hydrogens? So the hydrogens, this is when the presence of hydrogen comes into play. So when cracking is occurring in the presence of hydrogen, it means that this hydrogen is part of the reactants. This hydrogen is part of the reactants. So instead of saying we have 10 hydrogens, instead of saying we have 10 hydrogens, it's as good as having plus 2. As good as having plus 2. So on the product side, the same as you have 12 hydrogens. So what do we do to balance the number of hydrogens on the other side? So to balance the number of hydrogens on the other side. So this will be the 6 which is here on the product side and 12. So the y will be equal to 12 minus 6, and this will give us 6. Therefore the H will also be C2H6, which is also known as ethane. So the cracking in the presence of hydrogen produces alkane. So this is an alkane and this is an alkane. So that is the cracking in the presence of hydrogen. Let's look at another example. Let's look at another example. First. So the same principle applies. The hydrogen which is on the arrow sometimes can be put on the, or can be represented on the reactant side. So the hydrogen in the, cracking in the presence of hydrogen The hydrogen is part of the reactants. That is the key thing we have to remember. Let's look at another example. So let's say we have C8H10. So this is called octane. This is called octane. So when octane undergoes cracking in the presence of hydrogen, so sometimes they cannot put the hydrogen on the arrow, they can just say plus H2. So it means that cracking was in the presence of hydrogen. Then here we can get maybe let's get C3H, C3H8. So this is called propane. This is called propane. Then we are asked to find CXHY. So remember the same principle. C, we have 8. What about the hydrogens this side? So 18 plus 2. So we'll say 18 plus 2. This is as good as 20. So here the C is 3, and then the H is equal to 8. So to find the X, we just check what is on the reactant side. We have 8 minus 3, so this would give us 5. Then what about H? So H will be 20 minus 8. This would give us 12. Therefore, this is C5H12. And what is the name of this? So this is called pentane. This is called pentane. So basically that is the cracking in the presence of hydrogen. So in questions they specify such and such hydrocarbon goes cracking in the presence of hydrogen. So if they say in the presence of hydrogen, this is how we're supposed to do the working. Now let's look at cracking in the absence. In the absence of hydrogen. So there is no hydrogen involved. So when we have an alkane, and then it undergoes cracking, so you don't show the hydrogen on the arrow. So this is the absence. You produce an alkane plus a different homologous compound known as alkene. So there is a difference. E-N-E-A-N-E. Let's look at an example. C2, let's use C4H10. So that is butane. So butane undergoes cracking in the absence of hydrogen. It produces an alkane of C2H6. So this is butane. This is butane, and this is ethane. So that is the alkane produced. What alkene compound is going to be? So this will be CXHY. So what alkene compound is going to be produced? So the same principle, we'll just look at the number of atoms if they are balanced. So this will be the X will be 4 minus 2 giving us 2, and then the Y will be 10 minus 6 giving us 4. Therefore this will be C2H4, and this is an alkene known as ethene. Very soon we're going to look at this group of homologous compounds. So this is called ethene. So in the absence, you produce an alkene and an alkene. So that is cracking in the absence of hydrogen. So basically, those are the two types of cracking: in the presence of hydrogen and in the absence of hydrogen. So just to get back to the slide, that is what was being demonstrated in the slides. Yeah, so cracking in the absence, you get an alkane plus an alkene, and those are the examples. Then cracking in the presence of hydrogen, you get alkane plus alkane, and that is an example. Cracking is a very, very important process in chemistry, as it produces hydrogen on a large scale. So cracking, in this example, we have ethane, which produces ethane plus hydrogen. So cracking can produce hydrogen, and hydrogen is a very cardinal gas in chemistry, which is used for many purposes. So it is used in the manufacturing of margarine, the manufacturing of plastics, and so on and so forth. It's also used as petrol. So cracking is one of the industrial processes that is used to produce hydrogen on a large scale. So basically that's what I had for you for today's session. So remember, cracking is a process of breaking down a large molecule into smaller molecules. So we have two types. We have thermal and catalytic. Thermal, we use heat. Catalytic, we use a catalyst, such as aluminium oxide and silica or silicon 4 oxide. And then we have cracking in the presence of hydrogen, where an alkene and alkene is produced. Then we have cracking in the absence of hydrogen, where an alkane and an alkene is produced. And then cracking is also an industrial process that produces hydrogen on a large scale, and hydrogen is used in so many industrial for so many industrial purposes, which is manufacturing of margarine, plastics, and petrol. So that was just what I had for you for today. It has been your host, Mr. Mansa. Until we meet next time, bye.